So our next topic in this unit is equations of lines. Our goal, I can find the equations of lines in both slope y-intercept form and standard form. So in grade 9, we do take a look at the different forms. In grade 10, we're going to spend a lot more time working with those two forms when we're working on questions. So slope y-intercept is pretty obvious. So it's called the slope y-intercept form because we can pick out the slope and the y-intercept from the equation pretty easily. In standard form, notice that everything is on one side equal to 0. A, B, and C are all integers, so that means no fractions when it's in standard form. And A is greater than 0, so when you write it, whatever number is in front of x, that has to be a positive value. Okay, so we'll go through some examples here, and you'll see how these are related and how we switch between forms. So in example 1, we're going to go from standard form to slope y-intercept form. So you can see we're starting with this equation here that is in standard form. So our first step is we're going to move the x term and the constant term away from the y term. So really, what we want to do is try and get y by itself, because remember, we're trying to make this equation look like that. So I'm going to move the 2x and the negative 16 to the other side. So I'm going to leave 4y on this side. Now I only have 0 over there, so I just need to change the operations for the two things I'm moving. So 2x changes to minus 2x. Minus 16 changes to plus 16. The next step is to divide each term by the coefficient of y. So the coefficient of y is 4, so I'm going to divide this by 4, divide this by 4, and divide this by 4. So there's 3 terms there. We're dividing each of them by 4. And what we end up with, the negative 2 over 4, we can put in the lowest terms. That's going to be negative 1/2. And 16 divided by 4 is 4. So now we've got the equation in slope y-intercept form, and now we can very easily pick out the slope and the y-intercept from that equation. All right, now we're going to go backwards. We're going to go from slope y-intercept form to standard form. So you can see we've got our equation here that is in slope y-intercept form. We need to make it look like this, so we need to put it in standard form. So the first thing we have to do is multiply each term by a common denominator to clear the fractions. Now if you don't have fractions, you don't need to worry about it, but oftentimes the slope at least might be a fraction. So in this case we've got 2 fractions. Our lowest common denominator for 4 and 6 would be 12. So I have to multiply each term by 12. So that means I have to multiply this term by 12, I have to multiply this term by 12, and I have to multiply the third term there by 12. And the reason that I'm multiplying by the lowest common denominator is to clear the fraction. So what happens here is I can divide 4 out. 4 goes into 12 3 times. So now that fraction's gone. And with the 6, 6 goes into 12 2 times. So now that's gone. So my next line now, I'm going to clean up all the garbage here, because now it's a complete mess. But 12 times y is going to be 12y equals, and then I've got 3 times negative 3x. So that's going to give me negative 9x. And then on the end I've got plus, and then 2 times 5 is going to give me 10. Okay, now I need to rearrange to get one side equal to 0. Okay, because that's what we want to do for standard form. And the terms in order on the other side. So the x term comes first, then the y, then the constant term. Okay, so if I do that, I might as well just move 12y to the other side. So I'm going to have 0 here. I'm going to write the x term first. The 12y, when it moves to the other side, changes to minus 12y, and then plus 10. And then if the x coefficient is negative, remember we need it to be positive, then multiply every term by negative 1. So if I do that, I'm going to multiply this term by negative 1. I'm going to multiply this term by negative 1. I'm going to multiply that term by negative 1. So my final answer here is going to be 0 equals negative 1 times negative 9x. Sorry, and I'm actually, I didn't write this here, but I should show it. I'm actually multiplying the 0 by negative 1 as well. And if I multiply 0 by negative 1, it's just going to be 0. So now on the other side, you see what happens. If I'm multiplying by negative 1, I change the x to a positive coefficient. And then negative 1 times negative 12y is going to be plus 12y. And then negative 1 times 10 is going to be negative 10. So that's what the equation looks like when it's in standard form. Okay, so finding the equations of lines. So we've got two methods for finding the equations of lines. So in method 1, we're going to use y equals mx plus b to find the y-intercept, then write the equation of the line. So example 1 says use y equals mx plus b to find the y-intercept of a line that has slope of 6 and passes through 1, 3. Then what is the equation of the line in standard form? So important pieces of information here. The slope is 6, so I'm going to put down m equals 6. I also know that the line goes through this point. That means that that point represents an x and a y. So my first step here then is I'm going to sub in the slope and point to find the y-intercept. And remember, in our equation, the y-intercept is the b. All right, so I'm going to start with y equals mx plus b at the top. And now I'll sub in what we've got there. So the y value up above here is 3. So I'm going to put 3 in where the y is. The m I have over here, that's 6. The m and the x are multiplying together, so I'm going to use brackets here. X is the 1 from up above here. And then I don't know what b is, I have to find that out. So I end up with 3 equals 6 plus b. 6 moves over and changes to subtraction. So I end up with b equals -3. Now I know the slope and the y-intercept of the line. So my last step is to sub m and b. So we're going to sub those in to get the equation of the line. So in y equals mx plus b, it's going to be y equals m is 6, x, and then b is -3. Now I need to change that, change to standard form. So sometimes they'll ask you to write it in different forms, so you need to be aware which form they want it in. Here they want it in standard form. So standard form means we move everything over to one side. The x term comes first, then the y term. So the y moves over, it becomes -y, and then -3 on the end. And that's what it would be in standard form. So that's one method we can use to find the equation of the line. Another method we can use is we can use the slope point formula. So if we know the slope m at a point x1, we can write this equation down here. So y minus y1 equals m x minus x1. So the m ends up going in where the m is, and the x1 and the y1 end up going in there. Okay, so we're going to do that same thing for the same question we had up above. So if I'm going to use that formula, my x1, and my y1 are these two values here from the point, and my m is the 6. So I'm going to start by writing down that formula. So y minus y1 equals m and x minus x1. And now I'll plug in those three values into their proper spots. So it's going to be y minus, and there's my y1 is 3, equals, the slope is 6, so that's going to go in front of the bracket. And then it's going to be x minus, and x1 is 1, so it'll look like that. And now I just need to get rid of the bracket, so I'm going to distribute the 6 inside the bracket, and then I'll put it in standard form. So it's going to be y minus 3, and I multiply the 6 inside. 6 times x is 6x, and 6 times -1 is -6. And then I'm going to move things over to the right side. So I have 6x. The y is going to become -y. I've got -6. And then that -3 moves over and becomes +3. So when we simplify that, you can see we end up with the exact same answer there. So those two methods, you can use either of those methods to solve these questions. But I am going to show you when it's helpful to use one or the other here. So in example 3 here, find an equation using slope and a point, but the slope is a fraction. So when the slope is a fraction, method 2 is easier. So I'll show you how that works in this question here. So we've got our x1 and our y1, and we've got our m. So I'm going to go ahead just like I did in the last one. I'll write down my formula. Okay, so there's my formula, and now I'll plug in my three values. So y minus 3 equals, so there's our fraction slope, and you'll see why that's helpful in these questions. And then here I've got x minus, and it's x minus negative 2, so it changes to x plus 2. So remember, if I have x subtract negative 2, these two negative values, here and here, become a plus. So that's where that x plus 2 came from. Now here's the key step here, is because of this fraction, our next step is going to be move 5 to the other side. And because it's dividing, when it goes to the other side, it's going to change to multiply. So here's what that's going to look like when we move it over, is we're just going to write it in front of that bracket, or in front of the y minus 3. So we'll put the y minus 3 in a bracket, and then we just have the 2 in front of the bracket on the other side. So this is going to end up being 5y minus 15. So we're just distributing, multiplying the 5 inside. Then we're distributing the 2. So we're going to get 2x plus 4. And then we'll move everything over to one side. And when you move it over and you simplify things, you're going to end up with 0 equals 2x minus 5y plus 19. So that's the deal with that one. So that's why it's easier to use method 2 when you have a fraction exponent. Now this example, the last one we're going to do, we're going to do this tomorrow in class for a while. This has already gone on long enough. That's a lot of information. We can clarify anything for you tomorrow, and we'll do example 4 together as a warm-up. Thanks.